Welcome to Lesson 9 of our Computer Systems unit. In this lesson we will look at translators. We will look at the need for high-level languages to be translated to machine code. We will look at two specific types of translator, those being interpreters and compilers. Here are our learning intentions for today's lesson. By the end of the lesson, you'll be able to highlight the difference between machine code and a high-level language, discuss why we need to translate languages. You will also be able to describe how a compiler works and an interpreter works when it's translating between high-level and low-level languages. As with every lesson, we have a series of success criteria which should be referred to on a regular basis throughout the lesson. For today, our success criteria is: I can highlight the difference between machine code and a high-level language. I can discuss why we need to translate languages. And I can describe how a compiler works. And I can also describe how an interpreter works when translating. We're going to discuss two types of languages firstly. First, machine code. The machine code is made up of binary. We learned this earlier in the unit. The machine only understands ones and zeros, binary. It is made up of two symbols, a 1 and a 0. Machine code is a two-state language. It can represent 1, 0, on, off, or true or false. High-level languages, on the other hand, such as Visual Basic and Java, are written using some English words. This allows us to type out our programming code or syntax using words we are familiar with. These programs are not written in English, but they do use some English terms. In this slide you will see some examples of high-level languages. You will also see next to them their common use. For example, Visual Basic is normally used for education, whereas Prolog is used when working with artificial intelligence. Machine code is a language the computer understands at the lowest level. It's referred to as a low-level language. I mentioned this earlier on in our learning intentions and success criteria. In machine code, instructions are made up of binary numbers. Machine code is very complex and challenging for humans to read, understand, and interpret. It is made up of ones and zeros. However, the computer needs the information in machine code, or those ones and zeros, to understand the instructions it's been given. Programs written in high-level language, such as Visual Basic, need to be translated from that high-level language into a low-level language or machine code so that the computer understands the instructions we are giving it. Hopefully, we now have a basic understanding of why we need to translate high-level languages into low-level languages. The source code you write is instructions for the computer. These are written in high-level languages, such as Visual Basic. All programs that are written in a high-level language need to be translated into a low-level language or machine code before those instructions can be carried out by the computer system. We use translator programs to carry out this task. In this example, you'll see some high-level language source code on the left-hand side in the white box. The diagram then passes that to the translator before translation takes place into low-level language machine code, or ones and zeros. Don't worry if you don't understand what the high-level language source code means at this point. This is just being used to illustrate the process. There are two main types of translator program that we will discuss in this lesson. Those are compilers and interpreters. Both translate high-level language source code into machine code. Let's start with our compiler. Our compiler translates high-level language instructions, which is called source code, into machine code, which is called object code. It goes through the source code one line at a time and translates it. It puts the translation into a file and then moves to the next instruction. When the whole program is translated, the machine code can then be run. Once this is done, you will never need to translate the source code again, unless there is an error or the program has been changed. If there are any errors, it will inform you in a list at the end of the translation. This is normally used when a software application is finished and fully tested. The application can then be used in other computers. As with anything, compilers have advantages and disadvantages. Let's look at some of them now. In terms of advantages, if no errors are found, the source code does not need to be translated again. When the source code has been translated, the compiler is never needed again. That means it does not have to reside in active memory. It frees up resources. This also makes software applications portable, which means they can be run on different computers. Applications will run faster on future occasions, as no further translation is required. There are some disadvantages. If any syntax errors are present, the program will not run. The errors can be more difficult to correct, as they may not be visible until the translation is completely finished. In this slide we will see a compiler in action. As you can see, we have some original source code typed out in a high-level language. This is then passed to the compiler, which then translates this high-level language into low-level machine code or object code. As mentioned earlier, every line of the source code will be translated and stored in a file until all the lines of the original source code are translated. At this point, we will then find out if there are any errors in our code. If not, this code can then be saved and ran at a later date without the need for translation. Now let's look at our interpreter. The interpreter does not produce any object code like the compiler. It translates and executes every line of the source code in turn. The interpreter is always loaded into memory. Error feedback is given one line at a time, not at the end, as like with the compiler. The interpreter is required each time the software application is run. Therefore, it must be loaded into active memory. Interpreters are normally used when software is under development. And some advantages and disadvantages. Using interpreters, it's easier to fix any code as the errors are highlighted to the user immediately. Interpreters can also run incomplete code, perhaps in a development environment. Interpreters are usually built into software development environments for this purpose. Some disadvantages to the interpreter. The translation is not saved, as like with the compiler. The interpreter must be present every time the code is run. This means that the interpreter must reside in active memory. It takes up more RAM. If the code is repeated, like a loop, the code is translated and run many times. For example, the code would be run 100 times in the loop and translated 100 times. Applications will take longer to run as they have to be translated each time they are used. This slide shows an interpreter in action. Again, we have some original source code typed out in a high-level language. This is then passed to the interpreter. The interpreter will take each line of source code and translate and execute it in turn. It's at this point we will find if there are any errors, not at the end, as with the compiler.